Hey everybody, happy Monday again. All right, we've got quite a bit today, kind of all over the place. So we missed 725, so we'll talk a little bit about regex, a little bit about network programmings. I want to focus on Python and web services because I think that's super useful, dealing with some sort of web requests and working with data coming from that. We'll talk more about the Python objects, the lab. I want to spend a little bit of time thinking about the final project using classes. Now, it's pared down a little bit because we only really have the 3 weeks. So you don't need to use classes for anything here. I think they're always useful and good for us as we're trying to solve how we could solve problems to use classes, because it helps us talk about things in more of a natural human way here, rather than, hey, I've got a list and the first thing in the list represents this, the second thing in the list represents this, the third thing, and tracking all that's kind of annoying. So if we can create an object and have attributes, life is just a little bit nicer here. And then we'll get to Python and databases, which is also super helpful. But given there was no database prerequisite, I don't want to go too deep in here and lose anybody who doesn't know anything about databases, because that's okay. But if you do know stuff about databases, we'll see, like, here's how you can interact with the database in Python. You can literally go and do anything you want. It's super cool. You just run code and it will talk to the database. So we won't focus as deep on that tonight. So we should be able to get through everything in not too much trouble, I think. Thanks for the sound check, Brian. And then next week, visualization and plotting. There are so many different ways for us to visualize data and to graph it and represent it here. There really is an art to telling a story with data. So we're just going to look at some tools that let us visualize it here. You can take entire classes on how you can present data and graph it and show it in certain ways to tell stories. And hopefully you'll take the right approach and not lie with your data. But it's very easy to show data in a certain way to make some point, right? And if you are aiming to show something with your data, you can probably make the data show that, rather than let's see what the data actually says here. So there's some fun things there. And then 2 weeks from tonight, then, are our final project presentations. So it'll be your folks' turn. We'll have a Zoom call for people to join. It won't be on Twitch because you'll actually need to share your screens. The idea is it's 5 minutes or so, 10 max. It shouldn't ever take anybody 10. And I did have somebody who's like really excited and went a couple extra steps because they thought this was really fun. Apparently they're a fan of blackjack. So maybe they'll hit 10, but that's like extra stuff. So you run your program, show us the results, and then show us around the code. Say, this was interesting, or I had to solve it this way, or anything you found interesting. I usually try and ask for suggestions or notes, what you'd recommend the next time we run this class that they should do for their final project, or any tips or tricks. And that's it. So it's relatively painless. I do want you folks to have some practice presenting in front of peers. So mainly the audience is the other classmates, right? Obviously I'll be back here scoring it, but we'll work on the rubric tonight as well. I don't think I posted a rubric when we did the project last week, so we'll get the rubric. So before you're ready to present, you should be able to check off, hey, I did this, I did this, I did this. Great. If it works, you get the points. But I do need everyone to present because that's how I see it working. I can score it right then and there, and it's good practice. So I generally don't like to give points for presentations because it's not the goal of it. Right? The goal is working code, but presenting it is a good thing to work on. So and that is the end of the summer semester. And then a week later, if you're coming back for fall, we start on 8/29 because fall semester is right off, coming right after that. So it should be interesting. All right, so do you want to talk about the lab and objects first, and then we'll come back to some miscellaneous topics? I think that'll work. Okay, so let's do that one first. We can do some labs on some of this stuff. It's not quite as interesting. The databases are difficult to do interesting labs with unless you have a whole bunch of database stuff to do. So we might skip that. there's one fun thing we can do with our web services we might do for a lab, so maybe we'll take a look at that. But other than that, not too much there. And visualization and plotting, I don't want to give you a lab that's due the last week of class. So maybe we'll do a small one on the web services tonight, and then that'll be our last lab here. All right, so let me fire up PyCharm while I'm at it. Take a look at our labs. This was our classes lab. All right, so we were going to write a class for electric vehicle. Remember, this idea of object-oriented programming has like 3 core components. One of the ideas is we're going to encapsulate. We're going to take all the details about a noun and put it into one nice little package. Another piece that goes with that is that we want to give people public functions that they can use to interact with our class. Right? So generally, when you have a noun, the things about it, all of its attributes, are attributes. Right? They will belong. There'll be variables that we store, and each instance of that class can have its own set of variables. Right? So just like you can have multiple chairs, you can have multiple cups, you can have multiple computers, they all get a set of attributes, we can set values for them. So for electric vehicle, we'll have max kilowatt hours, current kilowatt hours, color, make, model, and kilometers per kilowatt hour. I know this actually changes in real life and driving conditions and all that good stuff. We're just something basic here. Then our get methods are ways that people can access them. We don't want to give them direct access to our attributes. We want to essentially make them private. Again, Python's trusty. You still can do the bad things, but we'll try not to do the bad things. So any set methods, if you want them. So things that make sense for setting, right? Definitely color. You can definitely change the color of your car, but make and model, you probably don't want to have a set for, right? Because that really doesn't change. Once a company has made the car and it's this model car, it doesn't. I mean, I guess if you take it apart and put it back together with different pieces, it's no longer that model. But again, probably not too big of a deal there. Current kilowatt hours definitely changes, but we don't want to interact with it directly and say, hey, set the value to 50 kilowatt hours. That's not really how we would interact with this noun here. What we want is we want a charge method that says, hey, I want to charge it for this amount of kilowatt hours. That should increase it. And then a drive method, which says how many kilometers you want to drive, that will decrease the battery by so many kilowatt hours. So the current kilowatt hours will go up and down based on charging and driving. Right? So the public functions that are not gets and sets are really the ways that the things that the noun does, kind of verbs tend to be, right? So if you have a car, you can charge it, you can drive it, you can paint it, I guess. I don't know, it's a little bit silly, those sorts of things. So those become the public functions for us. And then we don't need any testing. I showed you testing last week. It's a good practice to have. I'm a big advocate of testing. It was another thing that we just didn't need to add on for the lab, so not too big of a deal there. Or just some test code if you want, is perfectly fine. And then raising an exception, right, is the correct way for our class to communicate with whoever called the function that a bad thing happened. We don't just want to print something, because who knows if, and I was actually looking at the console, if that will do anything here. If a bad thing happens, the class's job is to raise an exception and make sure it gets handled or crash. And really, no one wants their program to crash. That's just, it's bad for anyone to have your programs crash, which is weird that we sort of have gotten used to things crashing on us, but it's generally bad form if your programs crash. All right, so that's electric vehicles. Let me start up a new program here. Project, this will be lab 8. Do it in this window here. Hey, Professor Burp, thanks for dropping on by. All right. Now, again, you can put everything in this main py file if you want here. If you go and import it in another file, like when we did the testing, it can be a little messy here. So a nice thing to do is you can add a new Python file here. This will be our electric, let's see if I can spell that right, electric vehicle. It's probably close. So if you make a separate file for it, we can have it just be class code, and then if you want some code to run to test it, we would do that in our main file. And that's optional here, no worries if you didn't do that or not. It's not too big of a deal, but it's a nice convention. So we'll have our class for electric vehicle here, vehicle, And then we need the init method. So init's job, right, is to give all the attributes here. So we can come back and we can add some arguments here in a minute, but I need to list all of my self.something variables are my instance attributes. Each instance of this class, every electric vehicle I have in memory, of its own distinct set of these. And to mark them as private, our convention is the underscore. So we can have an underscore make is something, we can have a self.model is a something. And again, we'll come back and fill these in. I just want to list all my attributes here. Self dot, what is it? A max kilowatt hours, kilowatt, 2 T's, hours, 1 T, like 2 T's, max kilowatt hours. Again, we'll come back and give it some values. Self dot current kilowatt hours. Again, the 0, make, model, oh, color, right? Self dot color is something. Is that all we had? Oh, and kilometers per kilowatt hour. So it's self dot kilometers per kilowatt hour and 0. So which of these do we want to be passed in with the init? So when we make an instance, well, anything that we don't want to set for has got to come in with init. So if we're never changing make and model, you should have to give me make and model for sure. And then you probably need to tell me what the max kilowatt hours is. Generally, that only goes down as your battery degrades. Again, we're not concerned too much with how real life actually works here. So we'll just pretend that never changes and we just have a perfect battery, which if you could invent that would be amazing. But and then our current kilowatt hours is probably 0, right? Because until you charge it, right, by using our public charge method, it probably has no charge in it, right? I don't know, when you make a battery, does it like have charge? Or do you have to physically charge the battery once you've assembled? I don't actually know how any of that works, but we'll assume it's 0. It's probably fine. So how about, and then you can put these in any order you want. So how about color? So like a blue Chevy Bolt, right? And I'm just, apparently there's a unwritten rule on how adjectives are ordered in the English language. And if you do it wrong, it sounds really funny, I learned. But I don't know how that all came about to be, but it's true. And then a kilometers per kilowatt hour we also need. So kilometers per kilowatt hour. All right, so now we've got variables. That's a little long here, but on my screen, I'm so zoomed in. I can bump it down a line, I guess. But all right, so then we can set our values then to these ones. So if you tell me what the color, the make, and the model are, I'll set it to those variables. You tell me what your max kilowatt hours is, I'll set it. I'll leave current at 0, and then I'll take your kilowatt hours. I'm going to move this one down 1 just so they kind of go in order. Okay, there's our init method. So when you make an instance of electric vehicle, you have to give it these arguments, and they'll be set for each electric vehicle, any one that we want to load in memory. Okay, then we need some get methods, right? So we'll have a define for get color returns self.color. Remember, this self here is default for, these are instance methods. You can technically write methods without self. They're static methods. If you've done anything with object-oriented programming, we're not really getting into that because that's probably another thing that we don't need to worry too much about right now. It's a little bit more of an advanced topic. Usually we do that like in the second semester of intro to coding. So you can return the color, a define for get make, and these are a little bit tedious to write, but not too big of a deal. Return self.make and define get model, return self.model. So a lot of this is boilerplate, not super interesting. Get max kilowatt hours, we return self.max kilowatt hours. Now we can have a get current kilowatt hours, right? And we don't need a set for kilowatt hours, but we can have a get for kilowatt, like show, hey, this is how much charge is in the battery. Get current kilowatt hours, current kilowatt hours, right? And then kilometers per kilowatt hour. Fine, get kilometers per kilowatt hour. Turn kilometers per kilowatt hour. All right, so those are all of our gets. Now, which ones should we want to set? Well, you said set color probably makes sense, and maybe that's it. right? You're not changing the make, you're not changing the model. We'll pretend the battery never degrades. We're not changing kilowatt hours directly. That'll change when we drive and charge, and then our current kilowatt hours. And again, we'll just pretend you always get a fixed number of kilometers per kilowatt hour. So the only set we need then is color. So we'll have set color. Now that needs to be given a color argument. We can say my self.color equals the color. Now, if we wanted, the other great reason why we have these public functions is we could do some sanity checking, right? If there's an invalid color that you can't be, like the super ultra mega dark that you cannot use if you're Anish Kapoor, then we could do some sanity checking and make sure he's not allowed to use the ultra dark color. Other than that, I mean, it's kind of silly to validate some color here. But for our other variables, if you've got a valid range, that's why we have these public functions that can't be set to this value unless we accept it. Now, again, they can sort of go in and change it themselves, but they should not. So, and if you change something that's marked as private and it breaks, well, that's on you because you touched something you're not supposed to touch. Right? Then we need drive and charge. So how about we do charge first? We need a kilowatt hours to charge. Now, pretty much, we just need to increase our current for charge, right? And add to it. Now, we could do that sanity checking as well if we wanted, like, if you try to charge too much, it doesn't work. Most vehicles are pretty smart and they just stop taking current because otherwise your battery would probably do bad things and explode. So, yeah, if we wanted to add it, great. If we wanted to just pretend it's built in somewhere else, that's okay. But we could check it. I guess we could say, hey, if my kilowatt hours to charge plus the self.current kilowatt hours is greater than the self.max kilowatt hours, right? The amount you're going to add plus how much I currently have, if that's greater than max, we can raise an exception. How about a value error? Too much juice. Otherwise, then we can just take our self.current kilowatt hours, and add to it the kilowatt hours to charge. I think that needs that backslash. There we go. Sometimes it adds it for you. I haven't figured out. There must be a reason. So that's it for charge, right? We'll just add some juice to the battery and make sure we don't blow it up. Now, you could also make sure it's not negative as well. It might be a nice, smart thing to add here, right? We could say, or kilowatt hours to charge is less than 0. I mean, maybe that's the wrong value error here at this point, so we could add a separate check. Maybe that makes sense, right? If our kilowatt hours to charge is less than 0, invalid physics. I don't know, that breaks the laws of physics if you try and charge negative? Sure. All right, and then for drive, given a kilometers to drive. Well, we need to figure out how many kilowatt hours that requires, right? So we'll have a required, or I don't know, kilowatt hours needed. How about that? Kilowatt hours needed is going to be our kilometers to drive divided by the self dot kilometers per kilowatt hour. So if you tell me you need to drive 10 kilometers and you get 5 kilometers per kilowatt hour, right? 10 divided by 5 will be 2. You need 2 kilowatt hours. So then we can check if my self.current kilowatt hours is less than the kilowatt hours needed, we can raise a value error. Right? You did a bad thing here. Not enough juice. Otherwise, we can just deduct that, self.current kilowatt hours minus the kilowatt hours needed. And we've driven. Right? We've reduced the charge to say, okay, we drove 10 kilometers. That used 2 kilowatt hours. Here's your new amount. Sure. That's all it needs. So that's our class. And not anything super complex or interesting yet, but it's setting the stage for much more fun things. And as we look at that final project, writing some classes, it might be interesting as well. Have some public functions that do things, and we can go from there. So if we wanted to use it then, we could either write unit tests, which is, I think is a good thing to do. Most people won't, and that's okay right now. As you get further along in computer science, hopefully you'll have more chance to do that sort of thing. But for now, we can just say, hey, I want to, from electric vehicle, import electric vehicle. So it's from the name of the file, import the class name. here, and I can say, hey, I want a Bolt is going to be a electric vehicle. Mine was gray. I don't have it anymore. I'm a little sad, but that's okay. It was a Chevy Bolt, and its max battery, I forget what it was here. We'll just pretend it was like 80. I have no idea if that was correct or not. And I think I got about 3 miles per charge or per kilowatt hour. So that's 20 kilometers. It's like 4.5 or so, 4.6 kilometers per kilowatt hour, somewhere around there. I'm bad at that conversions, but that will make a new electric vehicle, right? We'll call it a init method with the color, the make, the model, the max kilowatt hours, and the kilometers per kilowatt hour. And then I have to charge it. So I'd say bolt.charge, and I want to charge it. Well, let's charge it all the way up here. Although, actually, mine, I never got it fixed with the recall. So they said don't charge it more than 90% because it could catch fire, which was pretty bad. And they blamed it on their battery manufacturer, which is probably fair. I don't know how that works in actual manufacturing physical goods, but if the battery breaks when you charge it 100%, it's probably a bad battery. So anyway, and then we could go drive it, right? And let's go drive. So it's about 10 miles, 12 miles from my house to here. So times 1.6, 16, 18 or so kilometers. We can drive 18 kilometers to get to campus here. And I can just print out my bolt dot get current kilowatt hours. So let's see how much juice is left in the battery. So I charged it to 70, drove 18, and I get 4.6. It should be 18 divided by 4.6, subtracted from 70. Look at all that quick math we're doing in our head. I have no idea what that is. It is 66.0, da 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 da. Sure. So it seems to be working so far. If we want to go nuts here, right, drive it more than I should, we get a not enough juice error. You can't do that. Please plan your road trip accordingly. Stop at the charging stations that may or may not be well lit or available or functional, and good luck on your road trip across the country. But yeah, if dealing with batteries after they've degraded is definitely a thorn in the side of electric vehicles being very green, Professor Burke. I don't know if we've actually solved that problem. I feel like we just keep kicking that one down the road, and we'll say we'll figure out a good way to recycle them later. I don't really know. All right, so that was essentially the lab. This part was totally optional. You didn't need the main file, but again, any code that's worth writing is worth testing and making sure it does what it's supposed to do. So us kind of playing with it here was one way to do that rather than unit tests. That makes sense? You okay? All right, cool. So let's spend a little bit of time talking about classes in the final project. I'll call this final project ideas here. So again, it doesn't need to be done with classes here, but I'm going to argue you could use some classes here. So I'll just make a new Python file outside of main for, what do we want to call this? Let's call it Blackjack. So you can have more than one class in a file as well. So we can have a class for like hand, and then we could have a class for card, and we could have a class for something else and other things, and we can have a bunch of these in here. So I actually want card first, and then hand really. When we define this here, it's going to have self dot, let's say cards, and again, private's the right easy thing to do. At this point, it's probably not too terrible if you just say, hey, cards is a list and just access it directly, rather than getting the copy here and adding cards. And you got lots of options. But if you wanted, you could define a add card method, given a card that would take self cards and append a card. You could do that, right? That sort of thing. And then card, right? If we were defined init method probably has a face and a suit, right? The face is like a 2, a 3, a 4, a 5, 6, 7, 8, 9, 10, jack, queen, king, ace. And then the suit is diamonds, hearts, spades, and clubs. That's a really weird order to say that in. That's how they came to my head. Right, one of the 4 suits. For our simulation, the suit doesn't really matter at all. If you wanted to like spit out some output and say this is your hand, what happens? The suit might be a little more important because it would look a little nicer and be prettier. But for now, that's fine. So if you tell it what the face is and what the suit is, great. We can have a self.face is the face and a self.suit is the suit. Right, we can just take those values. And then maybe you have something fun like a get card value, or I don't know, point value or something. And then you could say, hey, if the face is 2, return a 2. If the face is 3, return a 3. You could go nuts there if you wanted. Or you could just assign face a numeric value, just literally the number 2, and like the queen could still be 10. And behind the scenes, it will do what it's supposed to do behind the scenes. It won't look as nice. So you got lots of options for how you could do those sorts of things. If self.face equals queen, return 10, just one possible way. It does not have to happen this way. Just some ideas here. So we could make a class for card that could hold these values, and maybe we even then have a class for deck here, and then deck, when we init a deck here, has self.cards is a list, and then we could loop through and say for, now this is what suit in can just be hearts, spades, hearts, hearts, my goodness, clubs and diamonds, right? We can go through each one of those. If we give it, here's a little tuple. Now I have a suit here. And then for value in, I'm just going to cheat here and say range 2 to really 12. We'll give you 2 to 11. Sure. We could take self.cards and we can append a card given the suit and the value. It's, again, not actually functional here, right? Not fully functional, right? Because I'm only doing 110 and I'm skipping the ace or the jack and the queen and the king. Well, there's ways we can fix it, sure. But now deck now gets 52 cards, right? 13 cards, well, not really in this case, but each one of those here as we loop through. And then now I have a deck object that I could have a method like get card or shuffle or something, even add a shuffle, right? So we can take our self cards, and list has there's a shuffle. Where is it here? Python shuffle, random shuffle, yeah, random dot shuffle, random dot shuffle the self.cards. Thank you. Okay, so it'll shuffle, right? It's built in. You don't need to do anything particularly random yourself here. And then get card. Now, we can assume it's been shuffled, or if you don't want to shuffle it and get a card, you can just take the top card, or really like the bottom card. Anyway you want to visualize a list here, we can return my self.cards.pop. Or pop will take the last thing in a Python list and give it to you. So here you go. You can give it an index if you want a specific index, or just give it nothing here. If you wanted here in get card, we could pick a random index instead of having to rely on being shuffled. We could say, hey, give me a random number from 0 up to the length of my cards. That's an option, but that is a little slower than shuffling once and taking shuffled cards. And if we're doing this like 10,000 times, a little bit of slowness is going to add up. A little bit of, and it's not a lot of slowness, but a little bit of slowness is going to add up. Hey, White Paladin, happy Blur's Day, my friend. So we got lots of options here, right? And any way you want to make it work can definitely work, right? Now, the science of computer science and programming is making it work fast, right? The art of problem solving is just breaking it down into smaller and smaller and smaller problems. How do I get a card? It doesn't really care if it's fast or slow. We just have solved it, right? But then we can go and improve it and iterate on it and make it better and better and better and faster, whatever we want to. So if you shuffle first, then it's good. Or you could even do some silly thing like this if you wanted. You could say, hey, I want a self dot has been, or just call shuffle yourself, right? After we do this, we can call shuffle on our own, right? We could say, I guess we don't even need to shuffle it here. We could just shuffle it when we're done inside of a init. So you can't get at deck until it's been shuffled. That's an option, right? Or you can let the person shuffle it if you want, or all sorts of fun things here. And again, in actual blackjack, you generally have like 6 decks of cards at once that are all shuffled together in what's known as a shoe. I don't know why it's called a shoe, but they call it a shoe. And then you only play through like a couple of those decks of cards to minimize the effect that card counting has. So if you have 8 or 10 decks of cards, you only play through a small portion of it. It reduces the ability for you to count the cards and know, hey, there's more 10s in the deck or less 10s in the deck. Now is the time to bet more money, this sort of thing, to give you a bit of an advantage here in blackjack. Because it turns out casinos don't like losing money. Who knew? Wow. That's a real eye opener there. So lots of fun things we could do. And then again, hand and add cards, and maybe something you could do with cards then is a define get hand value. Right, and so we'll have like a, I don't know, value starts at 0 and for card in self.cards. Right, we're going to take value and we'll add in the card.get value, get card point value or something. Right, if you had methods that did these things, it would just work. Right, and then we're done, we can return the value. So ways that classes are kind of useful, right? We kind of break these things down into their separate nouns and say, okay, well, what does this noun do? What does this one do? What does this one do? And there's lots of different ways of going about it and different combinations of going about it here. Is this useful, this kind of thinking about this with classes? Again, not required here, but I want to throw it out here that it could be useful. It helps you break these problems down doing that functional decomposition. I don't need to solve the whole problem. I just need to know, hey, how do I figure out how many points a card is worth? Sure, okay, that's one problem to solve. Great. Now can we go on to the next problem? How do I have a deck of cards? How do we get a random card? Well, we can shuffle it and pick a random one. Sure. We got some options here. And then you add like is bust, define is busted or something, right? I'm just going to say return false. My game you can never lose. No, that's that sort of thing. You can fix this here. So lots of fun things that you can do. You can have a class for the dealer because the dealer has to take more cards. That one's a little bit trickier to do as its own class here. But if you wanted to go nuts with the idea with the dealer here, we could write a class for dealer. And then in the init here, we just take 2 cards, right? So maybe you tell it what its 2 cards are when you init if you want. That's fine. So we probably have a self dot. Do we have we had a hand, right? So self dot hand is a hand, sure. And then we have to get 2 cards. So if you wanted, you could pass it a deck and say, hey, when you make a dealer, give it the deck. And then you could say my hand dot append deck dot get card. And you can go nuts. You can have an object use another object, or a class use another class. So when you make a dealer, you have to hand it the deck and say, here's your deck, take your 2 cards. Sure, it could track that sort of thing if it wanted. And then, on dealer's turn or something, dealer's turn, again, it probably needs a deck here to pull cards off of. We could say if my self.hand.get hand value is less than 17, self.hand.append. Oh my goodness, come on, auto-suggest, deck.get card. Right, draw a card. Or really, I guess this is while, right? Get card, get card, get card, get card, get card. As long as they're less than 17, the dealer's going to keep on going. Not too much crazy logic here. It's just a quick little loop. If you can get the value of the hand in one nice little function like that. Again, it doesn't have to be a class, but if you have a class for hand and the hand can tell you what its total value is, great, it's done. The other cool thing hand can do now, right, as it's looking through the cards, it can say, hey, if I have an ace, we can try it with an 11, and if I'm too much, no, let's try it as a 1 instead, because aces technically in the game can be 11 or 1. I said, don't worry about it because it's more trouble than it's worth. We only have 3 weeks to focus on this. I know it's worth a ton of points, and I'm sorry. It would have been better to have a 4th week. It's just kind of the way things shook out because we had a shorter semester. So Ace said, the king, queen, and jack. Yeah, you could. Yeah, they're all 10. So you just, when you create the deck here, you just need to add them in more than once. Here, if you're doing strictly numeric values, or if you wanted, you could do the same thing and have the string values of 2, 3, 4, 5, 6, and check each one of those when you're looking at the card. Hey, if it quote is a 2, right, return a 2. Either way is perfectly fine, right? Any way you want to go about that's okay. It doesn't have to be a string value. It could be just a numeric value. And if you're doing that, though, again, you need to add a couple more 10s in there for each suit. And then lots of different ways of doing that here for you. If you wanted, because you don't need to say, hey, you had a queen and a 5, what do you want to do? Right? It's just a simulator. It's just going to say, okay, what do I do? My total's 15. I'm going to hit randomly, or I'll stand randomly and see if I win, lose, or draw. And we're going to track the number of wins, losses, and draws for each of the stands and each of the hits at each starting total. Right? So there's lots of different starting totals going from, We said 4 because we pretended aces were always 11 to make life easy. So from 4 up to 22, which is always going to lose, right? If you hit or stand, what's going to happen overall, right? How often did you win? How often did you lose? How often did you draw? And what we should be able to infer from that is the best choice of action is to always hit or always stand when you're at certain values. And that's when you look at that Wikipedia page. Goodness, I can't spell Wikipedia blackjack. So just for as a funny story, I went to make my second pot of coffee for the day this afternoon, and I have whole beans that I grind because I like that, and it's a fresher coffee flavor, and it makes me happy. So I did all that, and I put the water in, and I started the pot, and I go sit down, and I'm feeding my little guy, my toddler, and my wife comes down with the baby. She said, what'd you do with the coffee? So I just made a pot. Do you want some coffee? They were just napping, and she said, you didn't make a pot. I hadn't put the carafe in. So my entire counter and spilling onto the floor was full of a fresh pot of coffee that I did not get to drink. And I was really sad. But somehow I did the beans, did the water, hit start, and didn't have a pot in there to catch it all. So, well, ideally my head would have been there, just like drinking it right out of the drip. Like that's how I want it. I just want the coffee drip right in my mouth. But no. So that was a messy afternoon. Although my kitchen smells great now. The whole kitchen smells amazing. I love it. Anyway, so for blackjack, so the odds table here, this is what we should be able to infer from the data so that we don't have to go and say, oh, someone else already did all the math. We're not even actually doing any math. We're saying, I did a simulation here to get some results. Forget the math because that's hard. Like, honestly, I don't think I can do the right math to show this statistically. I'm sure someone can because it's doable. I just don't know the math for that.
Sorry, clear this chart. X means
stand.
Stand.
Yep.
And then H means pay.
Hit. Yep.
And then UH means.
So UH is surrender if allowed, if not hit. Mm-hmm. So like it doesn't matter what the chart actually says. Like our point here is that we'll be able to see for each total, I should be able to see, did I get more wins when I hit or more wins when I stood? And that's probably what we want to do, because when you're playing blackjack, the goal is to win. I mean, we know when we're playing blackjack, we're going to lose money because that's how the odds are. But the goal is to try and win and have some fun with it. So if you always hit when you have 12s, you're more likely to win here. This actually shows it across the dealer's face-up card, which we're totally skipping because that's another complexity we don't need. So in actual blackjack, the dealer gets 2 cards, but you only see one of them. So you get sort of a hint of what their score might possibly be here. So you know if they only have a 5, 4, 3, or 2, they're definitely going to have to take a third card. Because the highest that their next card could be is an ace worth 11. So you know they're going to take another card, and the chances of them getting 2 different 10s and another card and busting are higher. Again, that's why, and they stop at 17. So if they have a 7, there's a more likely chance that their other card is a 10, because again, there's 4 of those out of the 13. Doesn't mean that it always is going to be, but usually they'll probably stop at 17 if they have a 7 here. So if you're at 16, you should probably hit. If you're at 16 and the dealer has 16 or less, it's more likely they'll bust. But again, we're ignoring the dealer face-up side of here. We're just saying what gives me more wins, hitting or standing. And we're just going to do it a bunch of times and figure out what happens. This would be another fun thing to add in, but again, we have 3 weeks, so I'm not too concerned. Right, the goal here is doable, manageable here.
Yeah. So well, the players just assume the players have the 1 choice, 2 choice, 1 is hit, 1 is.
Yeah. So in the simulation, we'll just randomly pick. Okay, this time they'll hit. This time they'll stand, and just record what happens. So you can get really bad results. Like, hey, if I started at 5 and I hit and I got another 2, that was it. I now landed at 7. I'm probably going to lose. I might win a couple because the dealer will bust occasionally. But hitting at 5 versus standing at 5, you're probably going to win more often when you hit at 5 because you can't go bust when you're at 5, and you'll get a higher total. So it should show hitting at 5 has more wins than standing at 5, right?
Yeah, because I don't know the blackjack rules before, so I did look at the rules later after the master class, and then found out that okay, the players can have fade, stand, split, double, and
Yeah.
surrender.
Yeah, splitting is a whole other crazy thing, which is super cool. Again, but more complicated than we really need for our purposes. Just hit and stand, yeah. And double down is a whole other thing. You double your bet, which is fun. So if you have an 11, you're likely to get a 10. They always recommend you double down because you can win more and you've got more of a chance to win if you already know what one card is and all this fun stuff. But it's interesting. There's a lot that goes into it, but we're like, let's take a really simple version of it here to just, this is a fun thing you can do with Python code is simulate. Let's take a real thing and pretend to do it a bunch of times and see what the results are, which is kind of fun. Okay, so that is some classes here. I think we probably covered most of the functionality that we need here. Again, not, just some ideas. Doesn't need to use this, but there's an option here for you. Okay, so let me go commit that to GitHub here before I forget. And I'll put in a quick note here, like this is to do, finish me. Right, that's not actually functional yet, so but that's just some ideas here. All right, so we got Lab 8 and the final project. This is more classes. All right. Now we've got our miscellaneous stuff here. So let's go back to our book here. Take a quick peek. So the first one we want to look at is regex or regex. Regex. No one, I don't think anyone says regex. Regex, I think, is how most people say this when I actually hear them using it. And it's a whole regular expression is a thing. It's a pattern that you go and find. The idea is, hey, can I find some particular sequence that fits a pattern? And defining these patterns is crazy for what you can do with these. So the idea with pattern matching is you can get from specific letters to single wildcards. So it'll match anything to any number of wildcards. And the whole set of rules here is a little crazy. I don't know if he's got the table for it here. Extract data. So you can get some nonsense like this, which is really weird looking regex. They're a little tricky to use for sure, but they're super powerful in that we can now match stuff here with it. So the idea is this A to Z 0 to 9 means it can be any letter or number, uppercase, lowercase, or number. So you can do ranges inside of square braces. So what he's going to match on is any letter, upper or lowercase, or any number that starts something. So the first thing, if I find a letter or a number, it's possibly the start. Then this \s is a non-blank character. It has something here that's not a space or a tab or a new line, not a blank. And then the star means 0 or more. So I can have a letter and then as many other characters as I want here. Eventually, then I need an @ sign. So the idea here is he's trying to match an email address. There's a letter or number, and then eventually, no spaces, no tabs, no enters, an @ sign. So that's probably someone's username @. Okay, we're getting there. And then again, a bunch of characters, ends with specifically a letter. It's not checking for a .com or .org or because now you have unlimited domains essentially. That sort of hurt my head for like how we validate valid email addresses now that you can have .biz and .game and I don't even know all sorts of fun ones there. So the plus sign is a 1 or more of characters. The star is a 0 or more. So technically you can have like a@gmail.com as a valid email address. So you only need one letter technically. To find that account would probably be pretty tricky at this point in time, right? So 0 or more. And then, so he's like, let's take a look and see if we can't find all of these email addresses and spits them all out here. Essentially was the idea here with his regex. And you can do all sorts of fun things with regexes as well. So the caret character is the, hey, let's match on the start of a string here. So it has to start with something, and then it will have a 0 to 9 dot 1 or more. Right, this is going to get ugly, and you can find all sorts of numbers. Right, so he's looking for this X to start, then wildcard, so X dash, and then something. So a single period is an any character. The rules are crazy. There's like a whole table you can look up for regex here. I think that has all the fun ones. 0 or 1 occurrences specifically, 0 or more occurrences, 1 or more occurrences, matches exactly, matches a minimum, matches a maximum, matches a min through a max number. Like specific wildcards can be anything. Oh man, yeah, these are matches the starting position. This matches the ending position of a string here. So you can look like one specific line at a time when you're doing regex matches. All sorts of crazy things. It's a lot you can do with it. And actually, a bad regex brought down part of the internet. Was that a year or two ago? When what's that? The content provider Cloudflare had a bad regex update that they were doing as they were like parsing something, and it just killed half their network. It was really bad. I think there was a story about that. Regex at Cloudflare. Let's see. Yeah. There's a whole like they're really good about posting their something went wrong. Here's what happened. For the tech community. So the Reddit though, I thought they had their own article about it here, but let's see. Yeah, here it is. Oh, this is yeah. So the regular expression caused their CPU utilization to spike because it did a bad thing. It was matching too many that it shouldn't have matched or something. What do they have here? Here's like their CPU spike. Yeah, it was. These things are tough, and there was recently in the news. It's is it AI text parsing for regex? Is that it? They just came out with natural language parsing creator. It's just in the news. It's really exciting. Really excited for it. No. You could give it a human readable version and it would generate the regex for you. I don't know. Create regex from text. No. It wasn't AI or something. Was it AI? There was an article. I'll have to find it for you later. Ooh, was it this one? It's okay. Not that interesting, but you can do cool stuff with regex to match here. And it's built into Python where you can just ask for where you're going to search. So you import the RE for regular expression module. Then you can say re.search. And here's the regular expression. Here's what we're searching. And if it matches, it'll go and print it here. So a nice way of being able to search through and find particular items that match here. So you go through and find all sorts of fun things you can look at here. Looking for details of specific things, sure, why not? So lots of examples. Oh yeah, this is the summary, which is like the longest, I think, part of any of his chapters here. So know you can do it. There's all sorts of fun examples you can play with online if you want. I'm not going to spend much more time on it. We okay? It's cool. He's got some fun examples you can look at later. Fun matching stuff, but writing them is a big pain. There's I think it's regex tester. I think is what I've used before. I think this one's it. Yeah, so you can give it a regular expression with a test string. So like if I wanted to match something that started with a T, and then had some number of anything, so like a anything character, any number of them, and then dollar signs that ends with a T. Is that going to do it for me? Matches the T character, starts with a T, 0 or more of any character. No, it didn't match test. I did something wrong. So now it matches. Why doesn't it match the ends with T? But you can like play with it and see if it'll start generating things that match for you here. 0 more E to Z. Still doesn't match. Yeah, so you can do regex in almost any language. They're occasionally ever so slight, like they all should match the spec. Some do them a little bit silly here. And this one's like helpful. It's kind of like tells you what's happening here. So any character A to Z, any number of times, and then the ending string, is it T and then dollar? I did wrong. T. Oh, that one matches now, but that's just any number of characters. You can, I don't know. So there's fun things you can do. Regexes are hard, but right, where'd we go? So that was regexes. Then networked programs. We won't spend too much time. Again, there's some cool stuff you can look at if you want to do these. So if you want your program to either be listening for someone else to connect to it or to connect out to someone else's program that's ready for you to listen, we can do this thing called a socket. If you haven't taken a networking class, it's not going to make a whole lot of sense. Don't worry too much about it. But the idea is it's a two-way communication. So I can start up one Python program over here, start up another Python program over here, and they can communicate using that socket back and forth. Really, it just sort of sits and waits to get data here. And we don't, that's fine. So you could like go and get data with your socket to go and find something. That one's not as interesting for finding a web page. Yeah, getting the data or HTTP is silly. That's fine. Yeah, the URL lib is fantastic. You can get a specific request here, so you don't need to do this manually. Like, this is the manual way of going and getting some data. Like, hey, let's go and connect and send something and go get some data back out and all sorts of nonsense. Or we can just say, hey, can you just give me a web page, please? I just want to request this URL. We'll just go for it. And it works out pretty nice. Binary files. Yeah, so with the reason he wants regular expressions first is you can, if you want, parse your own HTML. I don't recommend you do this by hand, but you can say, hey, I want to find something specific here and look for specific requests and find some links and grab those links here. And these are all the links that you can get off of a specific python.org page. Sure, all sorts of fun options here for, whether or not we're going to match this regex here. Now, what's easier than doing all of that is Beautiful Soup. I don't know why it's called Soup, but Beautiful Soup is a library someone built and wrote, which lets you go and parse HTML directly. So when you deal with modules that aren't installed, you have to go and install them yourself. So Python came with a bunch of Python modules that were built into the Python language. Beautiful Soup is not built in, it's someone else's code, so you have to go get it. So to install it, usually I'll use PyCharm because that's easy. I can point and click to install it. Otherwise, there's a command line tool known as pip, the Python package index. I don't know why it's PIP though, but you can use your pip tool. And again, there's a whole link and you can go through and run commands to do certain things, to download whatever other modules you want here. But you can use Beautiful Soup. So for our purposes, if we wanted to, let's go take a look at, this is miscellaneous. I'm going to go to my project here and go to my settings, and I can go and add a module. So in my project Python interpreter here, I have certain packages. The packages are pip, wheel, setup tools. So if I want to go add a package here, I'm going to go click the plus and install a package. So I want beautiful soup. Beautiful soup. And there's a couple different ones. And this is where it gets kind of confusing and crazy, is you have to know what you're actually getting. So beautiful soup new, beautiful soup 4, I think is the latest and greatest version here. I think that's what they said, use version 4. Yeah, beautiful soup 4 is the latest version to use. So you'd say, hey, I want beautiful soup 4. Let's go install it, please. And it'll go download that module for me. And now I've got the package available. So now I can go use that package. So when we set up our project and we set up interpreters here, this virtual environment essentially gave me a copy of my Python install. Sorry, that's really tiny here, but it's not my C program files Python install that's on the computer. It's essentially a copy of Python. So when I add modules, it adds it to this specific Python interpreters modules. So the rest of my Python install, the rest of my computer can't use it yet. It's only downloaded it here. So that's one reason these virtual environments are nice. They kind of keep things self-contained. If you download a bad module and it's really bad, it could do bad things. So generally, you don't just download anything willy-nilly from whoever and go from there. Yeah, pip install BS4. Yeah, if you want it. So using the command line tools is great. I generally try and shy away from most of those because it's just a little trickier here. So now I've got beautiful soup 4. Now I can go and import it here. So sure, if I want to do a bunch of these things, I can probably just copy paste his copy here, and we'll see what we get. I'm gonna put a little credit here because taken from here. So it's going to import from Beautiful Soup. We're going to call it the Beautiful Soup library from the BS4 module. We're going to import requests, parsing here. Any breakpoints, I don't know why that's there. Let's give it a run. It says, okay, we need to enter a URL. Right? It's going to try and open that URL here. So where do we want to try and open? How about we try oaklandcc.edu? Oh, it crashed. Unknown URL. I didn't give it the whole thing. Probably needs the HTTP. http://oaklandcc.edu. There it goes. And it's going to go through and find every A tag. If you've done a web design class or anything with webs, you know A's are the links. So these are all the links from the oaklandcc.edu homepage. Holy cow, that is a lot of links on our one page. That's fun. Sure. So anything with the slash here will go after oaklandcc.edu. Sorry, those are kind of small here. I can zoom that in. Right, some of them are full links. Why we have a nice mix of those, I don't know, but sure, why not? ElusianRecruitment.com apply account create. Oh, is that our register? Probably. I think that's the register. A D2L login. Look at that. Another link to coronavirus and safety. Online services. So this is my old OCC. Wow, we still have a link to the old one on the homepage. Well, that's fun. Why not? There's a link for students. Constituency. I haven't been able to read those URLs in forever. Anyway, so sure, it worked. That was the whole point. So you can install the module and it just works, which is really fun. So Beautiful Soup is cool if you want to go out and get raw web pages. What we're going to look at next after we take a break, because I need to go get some more Coke, is using a API, which is not meant to be a web page that a human can go and open up and look at and read. It's meant to be processed by code and probably not needing some crazy library to say, hey, find all these, soup A, find all the A tags in here and do that sort of stuff. SSL, that is whether or not we're going to trust their certificate if we were trying to access over HTTPS. So we on some pages, who still has it here? I think it's this old page here. It says, hey, there's an invalid cert here. You're trying to go to a secure page. My browser says it's not secure because the certificate's invalid, so you can do all sorts of advanced things and look at it. And so it expired 197 days ago because they migrated to a different system. The old link's still here, but it forwards. So what this is going to do is say, I don't care. I'm not going to check the name to see if it matches here. Forget it. So don't go to bad URLs with beautiful soup, right? If you don't, I mean, trusting stuff on the web is a whole other fun story here with whether or not we trust them just because they have access to the cert or not. Okay. Yeah, so that's some fun stuff you can do. And yeah. Ooh, curl is really cool. But that's a bonus stuff. All right. Why don't we take a break and we'll come back and look at our web services, which is a much more interesting thing. Yahoo has a free finance API, so you can get stock data and build out a quick little, let's get some stock data, let's figure out if we should buy or sell. And obviously we'll make money in the stock market because it's so easy, right? Yeah. We'll have some fun. We'll make a simulator that can pretend to buy and win and lose money, and we'll see if it's any good. And then if it's good, maybe we'll do it. And of course, it was good a week ago, so it won't be good in the next week when we actually run it, and we'll be sad, but that's okay. All right, we'll take a break. We'll come back in a little bit and have some fun from there. What about 2 more minutes is 7:11. All right. Alright, folks, welcome on back. It's the wrong button. That one's the volume button. There we go. Alright, so I had a little fun with Beautiful Soup. I took it right from his page. I don't think we actually need to put this in our GitHub if that's okay with you. I'll just back that one out here. But I do want to look at this idea with web services. So when you deal with a web service, you're getting data back that is coded for machines, not for people. Right? Regular websites are for people, for us to read. Obviously, the computer has to figure out how to make it look, but it's meant for people to use. But the two most common ways of exchanging data for machines here are with XML and with JSON. And JSON is by and far much more widely used nowadays. XML is great, but it's a little bit more verbose. You can do more with it, so I like XML, but I think more people are going to this JSON or JavaScript object notation here. And so that's what we're going to take a look at. And what you get from that, and then like this is XML. It looks kind of like HTML, go figure. You can have the outer groupings, and then you can have attributes with values inside of them, and you kind of like have everything with a pair. So person has a name, a phone, an email, and everything. These are attributes of person. In JSON, give me my JSON here. It looks like this. So you get a set of curly braces, and essentially we can sort of think of this as a dictionary. And that will help things be a little easier in Python if we're familiar with dictionaries. So there's a key with the string name, and the value associated with it is Chuck. There's a key for phone. It has another dictionary inside of it. So the dictionary is associated with a value of another dictionary. That dictionary is a key for type and a key for number, right? And then associated values. And it has a key for email. The associated value is another dictionary with a key for hide. The associated value is yes. So like dictionaries with dictionaries inside of them, as far down as we want to go. And dealing with JSON, there's a built-in JSON library, which is super cool that we can use. So we're going to, we want to say import JSON, and we can just go load some JSON. So you say JSON.loads, and you give it the string for it to go load here. So you can write your own. I don't recommend it because we don't need to. We can just go load someone else's here. But if you wanted to, you could go and get some piece of information out here as you go. So the loads just sets that up for us. And then you can loop through it and get each top level as you go. So we're going to get for each grouping inside of it here. So this is one grouping, this is another grouping. We can get we're calling it item, the key of name will give me the value associated with name. So the first time that runs, we'll get Chuck, because the value associated with the key name for the first object inside of it here was Chuck. And then the ID and whatever X is, sure, X was 2. So you can go out and get some data here. So you can ask websites for information with their API or their application programming interface, and we can get some data back out. So where is, I don't want that one. I want the Yahoo one, Yahoo Finance API. This one was kind of fun. Which one did I use? Use this one? Where's the link? Stole someone's link. Where did it go? No. It's just on here for class, making sure this worked. Here we go. So you can get details about a particular stock here. Now this one is way more info than we need. The first one, we care about the second endpoint. Is much easier for us here. So we say, hey, here's the URL I want, and it is going to be query1.finance.yahoo.com/version8/finance/chart/ and then I give it the symbol that I want, like Apple or Google, or is it Meta now for Facebook? Or we could look up GameStop and see how they're doing. We're going to track some of the meme stocks. You can do all sorts of those fun things. So we're going to take this URL here. So I'll have my URL is going to be essentially this without the symbol to start. And then we got to import requests. Is it requests? Oh, goodness. Let me go back to his, because he did it just the previous chapter. Come on. Oh, look at this. We'll just go back ourselves. Why not? We'll steal all of his requests section here. EST requests. No. Oh my goodness. This one. Oh, the URL liver. That's where it was. Request. This one. URL open. I think that was it. Need all of those? Maybe we need all of them. We'll give it a particular URL. And so stock symbol. Which stock symbol should we look up? Should we look up GameStop? Look up GME, see how they're doing today? Why not? So we can put a request through. So we're going to get the HTML and open it out and read it here. I don't think we need the context. Yeah, we should be fine. So we don't need the context. We're going to go open a URL of URL plus the stock symbol. Right, take those two strings, concatenate them together. We can even do, here, let's do a formatted string. Why not? Of the URL and the symbol. Is that prettier? A little more conventional here. And read it. And then for fun, we're just going to print the HTML to start. We'll see what we get back out here. So we should be able to take this link here and see what we're going to get if we go here. So this is the result that we should be getting back. So not made for humans to read here, but we're going to take this and then we're going to go and parse it. Right, so we'll see, hey, there's a chart, there's results, there's data, there's currency, there's symbols, exchanges, all sorts of fun stuff here that we can pass through. Now I could give it some different options. I think we wanted a couple options here. So if you wanted interval and range, let's see. I think what was the default for range? Just going to be 1 day. Quote. It's fine. Probably enough here. I don't know if we need all the days, but so now if we run it, we should get back the same result here. Just it's all in one line because it's a little ugly here. So we can get the results. This was really our result here, and then we can say for item in result, we can print the item, and we'll see what we get here. So let's just loop through one at a time. There's a bunch of stuff in here. No, that's not what we wanted. We don't want one item at a time. Where did it turn that into? How did we get all those numbers? None of those look right. Well, we read it. GME. Let's load it up. That's right. That's what we needed to do. Sorry. So we can have our. We'll leave that at the HTML here, and then we can turn it into our JSON object here. So this could be our result. Is JSON.loads. Load or loads? I never remember which one's which. Loads with an S. Yeah, loads with an S. We can load the HTML. Then we can go through every item in the result and try and print that out. I think that'll work a little nicer for us. Well, the only thing in there is the chart. Sorry, that's a little small down here. There's one object. It's called chart. Well, that's true. Everything here belongs to the chart. The associated value is another dictionary. All right, so that's not really the nicest thing for us. So what we could do is we could put a breakpoint in here and look at it in debug mode, kind of explore it. Gives it a little bit easier. Sorry, it's going to be real small here, but I can see, once I step one more, you can see the result here is a dictionary. It has a chart. Chart has a result. Inside the result is timestamps, metadata. So all the metadata here tells us the currency, the symbol, the exchange, offsets, those sort of fun things. Trading periods, valid ranges, sure. Oh wow, that's all sorts of fun stuff here. The list of timestamps, those are fun. And then at each timestamp, does it give me? No, there's not prices. The indicators of the quotes. So I can get the close value. Oh dear, I clicked the wrong thing in. I can get the close value, the low value, the volume, the open value, the high value, all sorts of fun information about the stock for essentially along with each timestamp. Now really, I only want like 1 day, so we should probably see if we can pass that valid range in. We want interval of 1 day, I think. So we can say interval 1 day. Throw that in here. And interval equals 1 day. Let's see if we can throw that in. Nope, that's not an and sign. Okay, so this is a single day's worth of data. This is a little bit easier for us to look at here. Right, for just 1 day's worth of data to seeing what the open, the high, and the low were. Probably a little bit nicer here. So we'll throw that interval of 1 day in as well in our program. So let's add in the interval of 1 day. Now we should be able to get back out a little bit nicer data for us to see. Let's break it down here actually. Run it in debug mode. And now we can see in our result, we have the chart. The chart has the result, it has the first item inside of it, then it has the indicators, it has the quote. First item inside of that is, well, what do I want? How about the closing value? Right, well, to get to that, it's going to be a little bit tedious, but we can get to it. So if we wanted to say, hey, here's the closing price for the stock symbol, right, is going to be, we got to go find it here. So my closing price is going to be my result, key of chart. Right, the chart has a associated value of result here, key of result. That result has the first item inside of it here. Right, so then we want the first item, index 0, from that list. Then inside of that, I want the indicators. So key of indicators. Okay, and inside of that, I want the quote, key of quote. Inside of quote, then I want the first item. Oops, we're running out of room here. Quote, I want the first item, and inside of that, I want the key of close. I'll get the value associated with the key of close. Oh, but close is actually a list here, so I really only want the first item in that list. There. I think that ought to do it for us. Maybe. See if we can get that closing price to show up. So it should be 43.45, right? For GME, does that sound right? 43.4, okay. 44 is current value, right? So with some aftermarket trading, sure. So let's see if this runs. Stop and rerun. Closing price for GME, we found it. Look at that. All it took was the chart, the result, the first item, the indicators, the quote, the first item, the close, the first item. Again, not the prettiest thing in the world, but if we know what the format is, we can go and ask them, hey, what stock do you want to look up? Sure, we can go throw that into the URL here and go get some data back out. And if we want to deal with getting a larger interval and looking at across multiple days, we could say, hey, has the stock price gone up or down? And we can make some decisions based on probably more than just if it went up or down. But again, this is not going to be the smartest trading bot ever. We could change our interval if we wanted, get out some different data and say, hey, if it's trending up for a bunch of days, let's go buy it. If it's trending down for a bunch of days, let's not buy it. Or, I guess you're supposed to buy when it's cheap and sell when it's expensive. Don't take my advice for making money in the stock market. It probably won't go well for you. But, and this is using that API. So I just send a web request out. I'll go get that data, load it with JSON, and then I can essentially use it as like a dictionary, go through the dictionary, get the value that I care back out. And there's all sorts of fun web APIs that you can look at. So I think he had a couple listed with our APIs. So I think the first one he looked at was Google Maps. So if you want to look up some information from Google Maps, you can go get some information from, or you can send data in through his website, sure, through drchuck.net, and get some information back out, which is fun. The Twitter API, it used to be fully open. Now you need to use this OAuth, which is not the hardest thing in the world, but it takes a little bit of time. So turns out there's a way you can deal with it. You have to give it a token key and a token secret. You have to go figure out what those are for you, and then you can go and use it. They just want to know who's using it, essentially. So you authenticate to them, and then you can go and use it. And you'd say, hey, show me the whatever here. I want to know the count here for a specific user's timeline. And it'll go and work for you, which is pretty fun. And authentication is a little bit obnoxious. That's why that Yahoo one's kind of fun. But you can say, hey, give me your friends list here. And we'll go and get the friends list. If you give me the Twitter account, if you've gone through it and figured out all the API stuff. Right, so you can see, hey, here's the ID, here's a follower count, here's whatever their tweet is, locations, names. But again, the idea is that it is machine readable. So there's a specific format it follows so that every time you get data back, you can expect to have data in these particular locations with these given keys. And that's a lot of how we deal with data across the internet. I send a request out, get just a blob back, and if it matches a given spec here, I know where to go look for it. I can go get that information back out, which is really fun. Do you want to play more with the Yahoo Finance API? If we pretended to buy and sell and looked up prices and all sort, like we could change our specific days. I think you can give it the specific start and end, right? We can say, hey, I want a start date and end date here. Yeah, all sorts of fun intervals we can use. So you can do some fun stuff. Here's so like if you have multiple days, here's the lows across multiple days. So the timestamps are these UTC values, which is really annoying. Have a timestamp. It is the Unix timestamp representation. So it's the number of milliseconds since the January 1st, 1970, I want to say, epoch. Yeah, January 1st, 1970. I don't know why. We've been doing this for a long time now, where we represent dates and times with the number of milliseconds since then. Sure. Bad things will happen in 2038 because we will no longer be able to store those in a regular 32-bit integer. So future dates will be tricky on old systems. It's like the Y2K problem all over again. And now I feel old talking about the Y2K problem. Just reset. Overflows to 1. Yeah. I think everything should be patched by 2038. 16 years might be a bit ambitious, though, to say we can fix all of our systems that run here, because apparently one of the Boeing jets still updates with a floppy disk. Which makes me cry a little on the inside. But what do they say? If it's not broke, don't fix it. Just unplug it, plug it back in again, Professor Burp. Yeah, was it Boeing jet update floppy disk? Yeah, the plane's navigational databases are updated with 3.5-inch floppy disks. Has to occur every 28 days. Is this real? Is that seriously still? Okay, 2020. Yeah. Wow. Every 28 days. An engineer visits each month with the latest updates. Can you imagine that being your job? I have to walk around to these ginormous gazillion-dollar planes with a floppy disk. Say, here's your new maps. How do they even fit maps on a floppy drive? That's the impressive part. I think that's what I find most impressive. That's like 3.5 meg, right, on a floppy disk?
I suppose if you're just cutting it down to just like bare data, probably you are.
And it's just the updates, right? So what's changed? And maps probably don't change often, right? I hope. I mean, I guess like as ground shifts and sinks, you'd want your navigation to be like, hey, the runway's not at 27.5 feet. It's now at 27.4 feet. I don't know. It would probably matter.
It's not like we don't need like a giant, super high resolution image of the entire planet.
Yeah. Oh. Yeah. I don't know. Technology is interesting. Really, really interesting. And I don't build planes, so.
Yeah.
Diskette stowage latch closed. There's a sign to tell you that the latch is closed. What?
There has to be a story behind that sign.
Because if it's open, you don't know that it's closed or that it's not closed. Oh my goodness!
When they put a stupid sign up there's a story behind that or something like
that. Someone had a funny one. It was I think it was a clothing store. Had a big one of those big like wall size mirrors, and they had just a piece of paper stuck to it. Don't walk into mirror. So signs for everything, sure. So okay, this is a 737, not the 747. A slightly older plane, introduced in 1988. Wow. Oh no, this is 747. 737. Whatever. Fancy planes, still using floppy disks.
For the cost of playing, you want to try to replace
Yeah. I mean, if it works, go for it. All right, other fun stuff then. Databases. So dealing with a database, right? We did our little file storage with local files, and it totally works, but it's not a real scalable solution, right? Even if you have like a shared drive for files to be on. So databases are the way that information is stored because they maintain all of their own backup and recovery and access and all sorts of good stuff here, and they're fast. So the quick and easy one here is SQLite or SQLite. Because SQLs are structured query language. If you care about talking databases, that's a common thing. So the idea with the database is it's similar to a spreadsheet. It is kind of how we go about this. It has rows and columns. So each row represents, here's a distinct entry, similar to kind of like a class here where you have a bunch of attributes, and every column is going to be an attribute. So I can have, this page here, some row and some column here. Fun verbiage here. Our database books go nuts here, and people are weird about this, but it's a tuple is the row or a relation or the attribute. You can call them anything you want here. The relation is the table, the tuple is the row, the attribute is the column. They don't matter too much at all here. But if you want to get your own portable database with SQLite, there's a really cool SQLite browser you can use, which will go and let you work with databases right away. And we can go and import from SQLite and connect to our database and start adding stuff in. So you can just give it commands here with your connection. So we say, hey, I want to, in database land, we'll get rid of the table if it exists and load it up fresh, create the table. So it's going to make a new table for us called tracks. It will have a title, which is stored in text, and will have a plays, which is stored as an integer value. So databases are very particular and specific about what type of data you store in each column or each attribute, because they need to match, and they are really good at optimizing how that's stored and making it fast to look these things up here. So this will go and build out a new database for us. At music.sqlite, it'll make a little file. It'll create the table for us if it doesn't exist. If it did exist, we've blown it away and bad stuff happened, but that's okay. Excuse me. So it makes the table. Then we can start adding data. So with a database, you can essentially do 4 things. You can create data, you can read data, you can update data, and you can delete data. Those are known as our CRUD operations. So create, read, update, and delete. So to create data, our SQL word for this is insert. You say, hey, I want to put some data into what? Into the tracks table. I'm going to give it the title and the plays, and I'm going to give it 2 values, Thunderstruck and 20. Thunderstruck's actually pretty decent, I think, but I can't play it while I'm streaming on Twitch. Twitch will be sad at me if I play it. So these are substitute values. We're saying, hey, place something in where this question mark goes. I'm going to give it this value here. It's the right way to add data. You don't want to build your own strings. There's a whole story around SQL injection attacks, and that's really risky. So pass data in using substitute values will avoid that for you. If you've done anything more with SQL, you can give it nasty looking commands to do bad things to your database, and this helps protect against that a little bit. So this is creating the data. To read the data, it's known as a select. So we say, hey, give me some data. I want to find this data. I want the title column and I want the plays column from the tracks table. So look up the tracks table, give me the title and the plays, and go get it for me. And then I can delete data. And I want to get rid of any song that hasn't been played less than 100 times. So I'm going to say, hey, where plays is less than 100? So it will find every entry in the tracks table where the plays value is less than 100, and it will delete them. We're going to get rid of the unpopular songs. Sure, why not? Which would get rid of both of them at this point. So we can create data, we can read data, we can delete data. We haven't got to the updates yet, but you can go and update data as well. Does he have an update? Yeah, so you can update. So just like with SQL, we just pass it a string in Python and say, hey, I want to set the number of plays to 16 where the title is my way. So we'll say, hey, the song's been played, let's go increase it. And if we're Spotify, we'll go pay you 0.003 of a penny, I believe, is the streaming rate. Streaming royalties by service. Let's see. I think someone had a nice little chart here. This was probably not it. No. This one it? Someone had a really nice chart the other day. Here we go. So Apple Music will pay you 0.008 of a dollar. So 0.008 of a penny, right? That's not too bad. Amazon Music, 0.4 of a penny. Spotify, 0.3 of a penny. Okay, 0.3 of a penny. That's what it was saying thousandths. So I guess 0.3 of a penny. YouTube Music, Pandora. Pandora's still a thing? Wow. I thought they went away. Yeah, you can keep the music out of the VOD. I haven't bothered with anything like that, Professor Burp. That's a nice idea, though. Deezer. I don't know what Deezer is. I don't know what Title is. Should I be knowing these? I should know these things, shouldn't I? No, I don't want that handbook. Thank you. But anyway, you could increase the number of plays because we need to track this sort of thing for our music streaming service, and we need to pay some royalties as the music is streamed. I wonder, do they cut that down if you don't play the whole thing? Like if I just listen to 15 seconds of a track and skip it, do they still pay them the whole amount? Like, did that count as a stream? Maybe. Recorded music revenues went up to 21 billion in revenues. Wow. So Shadow says yes. Okay. Good to know. Good to know. Artists. Oh yeah, this is how much they're paying in royalties, not how much the artist actually gets. That's right, because the artist is only getting about 16% of that royalty payment. The rest is going to their label for whatever they do. I don't understand how the music industry works. Like, what service do these people provide that they should be getting 85% of the money?
I mean, it made more sense like 30, 40 years ago when the publishers had to go through like all the process of making deals with like record stores and record producers and all that, but makes a lot less sense in the streaming.
Yeah. Who is it? Someone was just making the news because like they finally got the rights back to one of their songs. Apparently, if you sign a record deal, you give up your rights to the music, and it sounds like such a horrible industry. Really horrible industry. The promotion, radio airtime, the money to make the album. Yeah, okay, I guess. I don't know. And then like you have to do it this way, or you can't break into the industry. I don't know. Seems real ugly. But the odds of like putting your own song out on YouTube and becoming famous are really low too. So what do I know? Maybe that could work. It worked for Tezande, so maybe it could work for us. Didn't he get a record deal from somebody? I don't remember if we got a record deal or not. That's okay. Yeah, not a good industry. I mean, there aren't many industries, right, that we would say really are good industries, perhaps. So working with databases. Anyway, the way to store data. This is really the way to do it. Now, SQLite still has a problem in that it's a local file, but it's a quick way for us to play with something and test without having to have some relational database management system up and running on our computer. Right? Installing and running your own database management system is a small pain, not the hardest thing in the world, but it's not the easiest either. So SQLite is great for us to play with and to test and to have some fun. But anything larger, we'd probably go say, "Hey, IT department, give me a database I can talk to," and they'll say, "Oh, sure, here's a database you go talk to." So instead of connecting to our SQLite file, we don't use the SQLite library. We'd use a different library to go and talk to an actual production database system here. For storing stuff locally, SQLite's great though. And so his example is as we start looking through Twitter here, I'm going to build out the database here. Yeah, and don't actually do it because they'll shut off your Twitter access. So the idea is that it's just going to start collecting and crawling and picking up information, so I don't need to go ask for that information if I've already gathered it once. And we can do the same sort of thing with our stock program. I don't need to go and store or go and ask for the data every time the program runs. In our case, we're just asking for one day. It's not too big of a deal. But if I wanted to go and say, hey, let's look up all the companies in the S&P 500, which should be 500, I think that's how that works, and go get their latest data, I don't want to go ask every single time 500 different requests, right? The Yahoo Finance API eventually will probably shut us down. I think you only get so many requests per hour or something like that. I forget what the limit is. But we could go and store that information then in a database. So he's following his Twitter example. But okay, let's go store it in a Twitter database. So we'll make a table for the friends, the retrieved, and the name here. And we'll go and find the Twitter account. We'll go through and go and get their information, and we're going to start loading it in as JSON. Get some data out, get their screen name, find their friends, see if we have any friends, right? To list in here, go and update their friends list. We can go and add it in here, add in the data. So when I go and ask, I don't need to go and get fresh data if I already have it in my database. Going through and building. So if we've retrieved the friends of this account and how many times it's been friended, sure, we can go through and loop and figure it out here. So it's a fun little example, and he goes, and this is a long chapter. There's a lot to do with working with databases. There's a whole database course, which is just the intro course, and then you can take like 2 or 3 other courses in specializing in database administration and database programming and going above and beyond. So if you're into databases and into that sort of thing, definitely check it out. We got some great libraries here in Python. I don't want to hit too hard on any of this. Again, we're not really going to do a lab on this specific database. Not too much for us to do here. Is that okay? Well, don't need to get super deep. If you're into it, we can definitely play and have a lot of fun with it, but we're not going to be storing anything at this point. So if we did a slightly more interesting project and we went with poker instead of blackjack, we could use a database to like store our results, which might be kind of fun. And say, hey, every time I run my simulator, I'm going to collect more results and collect more results and collect more results, because calculating this sort of stuff by hand is a little tedious. And it'd be nice if I could store my previous answers in a database. But again, we're doing okay. So we are almost done with Dr. Chuck's book. Next week we have data visualization. Don't give me any more ideas, Lord Taser. Yeah, yeah, you could store all sorts of things, across our blackjack data. Now, there's not too much to it with blackjack because we can get all the answers and have it all solved. But with poker, it's a little harder to calculate all the possible permutations and combinations, and they just go look it up now. Like when you watch, because everyone watches, if you watch like the World Poker Tour, they'll show what the odds of their hands are of winning, right? As the cards show up, they just get it out of a database. They're not calculating it on the fly. Yeah, Texas Hold'em was fun. There's lots of odds there that go into Texas Hold'em if you're into statistics. So fun stuff there. All right, so we are about done here. Then we're still working on the final project. I wasn't planning on another lab. I don't think there's really anything super interesting worthwhile to do the quizzes either. If you're okay with that, we can just call that an end to the quizzes. Because again, I'm not specifically into the database side of things. We're trying to focus more on what you do with Python. So if you're not familiar with databases, this chapter will suck, especially if you try to have a quiz on it. So not too big of a deal here. But the APIs are definitely worthwhile. Maybe we can play with that Yahoo Finance API, have a little bit of fun here with that, and do that for a lab. Does that sound okay? And then we'll have the rest of the night to work on the final project. So let me make sure I got all this code out here. So here's our miscellaneous. This was our finance API. All right. So what we want to do here then is we go to assignments and get a classroom link. So we lab 9. This will be our last lab. CIS 131 summer lab 9. If we make it, we don't need the lab next week, but 10 is a much nicer even number here. Template. But I'm going to drop the lowest lab score anyway, so it won't count all of them anyway for you. Should be okay. Excuse me. All right. So here's one last lab. 9. This is our Yahoo Finance API. Labs. There we go. So next week, 6 p.m. And you just need to turn in the URL. The URL to your program. So we're going to expand on the Yahoo Finance API example. Allow the user to buy and sell stock. So we don't need to be tracking too much here. Like we don't just, if they say they want to sell a bunch, just let them sell a bunch. They don't need to have bought that much beforehand or anything like that here. So we will ask the user to enter the stock symbol, and so enter the stock symbol. We will go get the current price, or really like the closing price is probably easiest. Though I don't know if it's going to have close all the time. Yeah. We want, because if the market hasn't closed yet, I don't think it'll actually have a value if we do the 1 day. I don't remember now. Yeah, is there? I don't know if there is a current. It should work with close. I mean, if you have trouble with close, let me know, but it should be okay. Yeah, this is our current timestamp. So what this is Unix 8 converter. Oh my goodness, convert. Yeah, okay. So to -4. So this is not 16 hours ago, right? Oh, is that 4 in the morning? 4 in the morning for the regular? Okay. Oh, that was the start. Here's the end. That's what it is. That on the end time. Sorry. Make sure we get the right dates here. Yeah, so that ended 9:30 in the morning. Okay. It should pull some dates here. I don't know. Regular post should have ended here, right? I think the market closes at 4 p.m., 8 p.m. Sure. But go get the closing data. That's fine. So we will ask them. We'll get the current price and ask if they want to buy or sell. If they want to buy, ask how many shares. I guess really either way. And how many shares? If they want to sell, ask them to enter the price at which they bought the shares. So we'll just say, hey, tell me what you paid for them. We don't need to track any of it. It'd be nice to like store this all somewhere and put it in a database, but that's its own final project. That would be more than we need to do right now. So they'll say, hey, I bought GME stock, right? And it was, is it more than a year ago? It went crazy? It was. I bought it back in 2020 before it went nuts in January of 2021 when it was $11 a share. Sure, and now I'm going to sell it at $43 a share. Why not? Right? And they can claim anything they want here. We can put all sorts of numbers in. Is it just this last? There's a big. Wow. That took a big hit. 150 down to 30? Are they in the news for something? I haven't actually been keeping up here. Okay. It was only so interesting for so long. Yeah. Oh, I mean, this, I think chart doesn't drag, does it? It went crazy. $325. So the theory here actually was really interesting, though, that the whole group got involved. If you get those big institutional investors and they're shorting the stock and don't own the stock to actually go and sell it at that price, then if all the other shares get bought up, they have to buy it at the higher price. So like it works if everyone joins in to screw the big institutional investors. So I don't know. Seemed fun. Probably was terrible, but was that really back the beginning of 2021? So that was year and a half ago. The pandemic had already been going on, right? We're like a year into the pandemic at that point, almost a year into the pandemic. Okay. The whole like since 2020, it's been really hard to keep track of anything relative date wise. I don't know about you folks, but yeah, it really has, which is awful. But sure. Oh, look, it was like $2.80 a share here if you bought it in April of 2020. We could have had from $2.80 a share to $300 a share. Not too shabby of a return. Sure, go for it. So we'll tell them how much money they made. Calculate how much money they made or lost from selling, right? So if you bought it at $300 a share and you're like, yes, I'm getting in on this because it's super exciting and it's going up, $300 a share is a good price to buy GameStop stock at, and then it goes back down and you sell it for $40 a share, you've lost a whole bunch of money, right? And sadly, some people did that with money they should not have been playing with. Which is, I do feel bad about that. Some people are getting screwed, but anyway. So if they want to sell, great. If they would just want to buy, just calculate how much it costs to buy that many shares. Right, so just some quick arithmetic here. Okay, then continue in a loop until they are done totaling. I can't spell totaling. All gain loss or all sold stock. So if they say, hey, I want to sell Apple stock and I want to sell Amazon stock and I want to sell Microsoft stock, keep track of that, and then when they're done, print the total gain loss. Right. So okay, you sold these 3 different stocks, you lost money on GameStop, but you made money buying Tesla. Good for you. your overall, now you're only down $500 instead of however much you lost on GameStop or whatever happened there. Does that make sense? So hopefully nothing too crazy. We've got part of it already written here to go get the closing price. So we just need to add in a little bit of extra stuff in here. But go out and play with an API, ask them what the stock symbol is, that sort of thing. Okay? And if you give it a bad symbol, you're just going to get back a message that is ugly. So where is that page here? So like if I tried to query for something, you'll get error not found. And then if you try and parse all of that, none of this will exist here. So like you could check then to see, hey, if there is no chart result, right? I guess if result is null, so you're going to get a chart anyway, but if result is null, we could check real quick. So if a result of chart key of result is null, is none here. Print invalid symbol, that sort of thing. So I think that ought to work for us. Let's run it again real quick. Oh, I hard coded in here, of course. Run that. We get URL not found. Oh, well, that was different. Oh, yeah. So I think we can check that with URL open. I think before we go and read it. Is that where it was? Where did it error? It errored at stack trace is fun. Line 8. Yeah, so it errored here when I tried to read. So let's get our HTML first. And then HTML dot. Something about like a status code here. I think that's it. Put that in debug real quick. Oh goodness, it didn't even go there. Results not found? How is that crashing already? Did we just do that and it didn't crash? URL open. Crash again. Ah, here we go. So now we're going to get this bad name not defined coming up. But if I step, nothing. Step. Okay, yeah, the HTTP error. There's a different place to catch that. It's fine if it crashes. Don't worry too much about it then. I'll just put that back. There's a better way to handle it. I'm trying to remember what it was. I think somewhere in request. I think before that's all right. So just let it crash if it crashes. Can you actually change any of that? I don't need any of that. That's fine. I'll discard all those. All right, we put it back. I never hit save. I'm sorry. There we go. All right, so we got that tonight, and then working on the final project, and that's all we got. Cool. All right, you folks online, find me on Discord or text me, send me an email. I'll be checking that if you want to meet up tonight. Happy to hop on, make sure we are on the right track for the final project. So, 2 weeks left, but I know you might have other things going on in the summer. So if you haven't started yet, please do start. That's definitely, we want to get that in for sure. All right, you take care. Oh, the final project rubric. Yeah, thank you. Thank you. That's the last thing we needed to do. That's right. So we've got 40 points here total, and we have a couple things happening. So we have our rubric here. So this is our final project. So we need, if it's complete or missing, essentially, complete. And you're welcome to give yourself partial credit if you're scoring, like when you evaluate yourself and see how you did on this. So I'm just going to break this down into 4 pieces here. So this is our the dealer logic. So they keep taking cards until they have 17 or more or have busted. Right? Getting that working.
17 or 16?
They should hit on a 17. I'm sorry, hit on a 16, stop on a 17. That's why all of our things say, hey, might as well try and break it. Yep. so that the dealer logic works there. Stops at 17 or higher. And then our player logic randomly picks hit or stand and tracks for each, just hit or stand, sure, and tracks result. This is going to be then our displays results for each starting value. Results, this is hit count, win, loss, draw count for hit and stand. So essentially you'll have 6 pieces of information for each starting value. So if I started with 4, how many wins did I get for hitting? How many losses did I get for hitting? How many draws did I get for hitting? How many wins did I get for standing? How many losses did I get for standing? How many draws did I get for standing? So it'll be up to us to interpret that result, but we should be able to go and essentially see what the strategy chart is telling us. You got to hit if you have 4, and that's not useful otherwise. And then the simulator runs 100,000 times and tracks all the results. So if you can't actually, that was a bad suggestion. Can I undo? No. Later runs 100,000 times, calculate all the results. So if you can just like get it to do it once, you get half the points here essentially. Half the points here is bad though, right? Because this is 40% of your overall score in the entire class. But at least get to there and you can still get a passing score. If you get it to actually do all the simulations and track all of these things, then we'll be much more successful. So no specific ways that you have to build it, just we're going to check those boxes off that the dealer works, the player works, we're displaying the results, and then we're actually simulating it enough times to get some sort of result out. That make sense? Okay, so we got a rubric there. Thanks for the reminder. You got plenty of time, Lord Taser. So I think you had added in some other fun stuff too, which is cool. We can take a look at that later. So again, card counting is nice. We don't need to worry about if it's actually suits and other values here. Any of that should be okay. So, all right. Any other thoughts, questions, or concerns? Let me know. If not, you folks take care, and I'll see you next week.